So guys, today we are going to learn insertion of data inside the binary tree using recursion. Using recursion. We can do the same thing using iterations. Okay. So first we are going to do it in recursion. So for that I am going to create here class node where integer data is present, which is our data, and I am defining two pointer of node type, left and right, left and right. So what actually happens when I have written it and run it, then there is nothing happen. Actually, when I have created the object of that class, then and only then this type of thing is generated inside the RAM. If you are not created the object of class and you run this, then there is nothing happens inside the RAM. So here I am writing a next class for tree to generate a tree, and generation of tree means insertion of node inside the tree. Now this node which we created, we are going to insert it inside our tree. For that I am here creating a root. This root consists the address. If because it is defined as a pointer, this is also pointer. Where there is pointer, it consists address. And if you got the root, you can access whole tree. Like inside the single linked list, if you got the head, you can access whole list. In the same way, if you got the root, you can access whole the tree. Then what I have to do? I have to first create a constructor to initialize my root. So root equal to null. So root equal to null. And what happens due to this? I have to make it public, because if I generate the object of this tree inside our main, like tree of A, then at that time this node is going to run. This constructor is going to run. Okay. So that's why I have to make it public, because it is accessed outside this class. Yes. After that, what I have to do? I have to insert the node inside the tree. Now from here our actual insertion of data inside the tree start. Now here our data is integer a, and this integer a I have to pass inside our tree. For that what I am going to do? I am created a, for that what I have to do? Listen, from here actual our insertion is start. Now this function is calling, we calling this function recursive. That's why what I am going to do, if I am inserted my first insertion, like I want to insert a, so from a dot I called insert a. Okay, so when insert 3, so this 3 is our a. Okay, so this a is accessed here, and I have to call this function again and again. So initially our root is null, we are making our root as a null. Okay, now what I am going to do, if, so do that, first I have to pass our root is here, so that's why I am making here node star name. Why I am doing this, you have to understand very carefully, because this node star temp, this node star temp is nothing but root. We are calling this function through the root. How we are going to call? We are going to create one of the overloading function, okay, which consists integer a. Now if you call a dot insert 3, then both functions are insert, but this function is called, because these attributes are different. This is called the overloading. This is the characteristics of the object oriented program. So here the overloading happens, and I am calling from here insert, I am calling insert root comma a. So why I am going to do it? Because this root is not public. Okay, and to make secure tree, to not access our tree by other functions outside our tree, we have to make it private. Okay, and we can't access our root in main function, so that's why I'm doing this thing. I'm calling the insert in the inside new insert. Okay, so what I have to do, if I am passing a root here, that means now our root is null, that means our temp is null. So if temp is equals to null, then what I have to do, I have to create a new node. How I am going to create new node? Temp is equals to new node. The moment I have write it temp equals to node, this thing is created inside our RAM. And the address of this thing, suppose this is created and its address is suppose A. What is the address of this? A. And this address is passed inside the temp, and this is our supposed temp. Then inside the temp it's passed. Okay, what happens here? New node is created and this new node is passed inside the temp, and after that I am making its temp of data is equals to A, temp of left is equals to null, and temp of right is equals to also null. Okay, now after that what happens, this temp we have to assign to the root. Okay, so now this root it can't access through this insert function, so that's why I have to return the root, return our temp, and that return temp I have to store inside the root. That's why I'm doing here root equal to insert of root comma. Okay, and here I am going to make its return type as node star. Now what happens, now this data, that means this 3 is inserted. Here is our 3, this 3 is inserted, this A is here. Now due to this line, that A is passed inside our root, and the function breaks, the function completed. Now again I am calling A dot insert with 4. What happens now? So when I call A dot insert 4, then also root and 4 is passed. What passed? Root and 4 is passed. So our temp is nothing but root and our integer is 4. So what we are going to do here, it compares root equal to null, but it's not equal to null. So what I have to do, I have to compare if else if temp of left, temp of data is less than, suppose our temp of data is our 3 and 3 is less than A. When these things happen, the 3 is greater than 4, that's why we have to insert inside right side. So that's why I'm here calling temp of right is equals to, now I have to pass here a new node with 4 inserted inside. So do that, I have to create here temp equal to new node and then assign temp of data, which we have did it before, temp equal to null. But to do that, what I am doing, I am calling the insert function again with temp equal to null. So how I get temp equal to null? Because only 3 is inserted now and temp of right is null. Okay, this is temp and its right is null. So that's why I am calling insert function again with null. It means temp of right. Okay, and after after that this else if ended and it returns the temp. When it returns the temp, it returns the insert function where from it is calling. So this insert is called from temp of write. So this temp is returned to the temp of write. That means if suppose this is the new temp, then this temp returns inside this function. So it returns here and value inside it is 4. Do you understand what happens actually? Insert function is calling for every node. For every new node, this function is calling and it stores the data. It stores its address inside the left or right. Just these things are happening. Now same we are doing for here. Else if temp of data is greater than a, then what we have to do? Temp of left is equals to insert temp of left comma a. Okay, what I have to do? I have to call the same function again, and it also returns the same thing again and again, again and again. And this, in that manner, our tree is going to create. Okay, so to if I want to insert a dot insert 2, then what? How it is going to happen? We can see here. So first, a dot insert 2 is called, then this passed here, and it create insert root comma 2. So now our temp is becomes root. So our temp is a now. I'm tracing here. Okay, I'm tracing here. Now our temp is a. Otherwise I can write here. Now our temp is equal to a. Now temp equal to a. A is not equal to null. Then a of data is compared with the a. So we are passing here. What we are passing? 2. That means our a is 2. Here our a is 2. So I am writing here this place a is equals to 2. Okay, and this a is the address and this is the integer what we are passing. So temp is the address of root a and this a is 2. Now temp is not equal to null, that's why it's passed here. Temp of data, that means temp is a, and what is the a of data? A of data is 3. So now 3 is less than 2. Is it true? Not. So it comes here. And 3 is greater than 2. Yes, it's true. 3 is greater than 2. Then this function is called. What is this function? Temp of left. What called? Temp of left. What is the temp of left? Temp of left. This is temp and its left is null. Temp of left is equals to null. Okay. So this temp of left is assigned through insert function. Now here insert called with temp of left, that is null comma a, and this passed where null equals to null, and then this new node is created and data assigned and left and right is going to null. So this new node can be C, and this C is assigned here, and this is our 2. And after doing this thing, it returns temp, but it returns to this insert function. Okay, the left insert function, and that insert inside the temp of left. And what is temp of left? This, and this is inserted through C. Okay, in this manner this insertion happens. After that I want to display. So what I am going to do, I am calling void display. Okay, but here also I have to put my root as private. I have to call two void displays, one is with root and other is without root. So what I am going to do, I am calling node star root here. or temp here. Okay, now I can display my tree in different methods: in order, pre-order, or post-order. So from here I am just calling display. So now here, what is in order? In order means first display left node, then middle node, and then right. Do you understand what is in order? I am writing here. First, print this thing. First, this is our root. Then check its left. Is there anything inside the left? Yes. Then again check its left. Is there anything inside the left? No. Then again check its right. Then print it. Then print 2 and then check its right. If this null, then this whole thing is null. Okay. And then we go back. Now same thing happened with these 4. There are no 2 nodes. And this all is over. Okay, so this is different tree, this is different tree, so we are calling the tree again and again. So first we call this tree, then its subtree, then its subtree, and then in that manner we are comparing our whole thing. So first, why are we doing in order? Because due to in order, our inserted data is printed in a ascending order. That's why I am doing in order. You can do is pre-order and post-order also. Okay, so first I am telling how to do in order. So for that, in order means display the root node in inside manner. How? Display, I am called display, and display temp of left. Now if I want to display temp of left, then I can go from 3 to 2. Again, same function is called temp of left. Again I go, but I can't define when we got the null. So moment I got the null, I have to return it. Okay, so if temp equal to null, it gets return. Okay, now what happens? Display temp of left. Displaying temp of left. When the left side is get null, now the left side of 2 is null. Now it returns. This means this displays the returns. This line is finished for that function, and it comes to here. See out temp of data. See out temp of data. So this displays, and then after displaying the middle data, I have to check right and then go back return again. So do that. What I am going to do, I am calling temp of right. Okay, this is the in order because we are printing it in. So if you want to do pre-order, you can withdraw it and print upside. If you do post order, then withdraw it and paste below side. Okay, so this is how we are inserting. So I can show you how I am going to insert 5 a dot insert 6 and finally a dot display. Okay, now these are printed in the ascending order. Okay, so I have to print it. So I am executing our code, compile and run. So I have to make it public to access it in below class. So that's why I make it public. Okay, now code is run. What it prints. nothing print, it's not printing anything. What happens here? Is there any mistake? So root equal to null, I have make it public. I call display a dot display. Okay, it's correct. Left, right, temp equal to null, then return. If temp is null, then return. Okay, it's correct, I think so. Again I can execute it. Execute, compile and run. What it shows? It shows nothing. So what is the problem? We should understand our problem. A dot insert void display C out temp of data. Is it correct? Okay, it's correct. Left, right, everything is so correct. What is the problem? It's node star name. It's also correct, there is no problem with it. What's the problem, man? Okay, here is the problem. I have not passed the root actually here. So to access our display we have to pass the root. So execute, compile and run. So what it gives? We can see here 2, 3, 4, 5, 6 printed. So this is our output in ascending order. Okay, so that's it, the insertion and display of the data, okay, inside the binary tree using recursion. Tomorrow we are going to see iteratively how to add the data and how to print it. Okay, so that's it for